Okay, sharp guys. Remember the simple rules, yeah? If you have any question, you're free to ask. You can speak into the mic, or you can just type on the comment section. Again. And then what are we doing today is statistics, right? So this is one of the topics we're going to be covering in the third term. I'm just going to quickly share with you um, the pay setter for third term, or the ATP for third term. Okay. So it is. Just quickly go there. Okay, I'll just take a screenshot of it and just share it at the end of the session because it's gonna take us time. Let's see. Um, yeah, let me share with you quickly. It's fine. Let me share with you the pay setter so that you guys know what's going on. So for third term, as you can see, under statistics, you're expected to revise, check item 1 to revise measures of central tendency and dispersion. The 5-number summary, that's the minimum, the maximum, the median, the Q1 and Q3, histograms, frequency polygon, ogives, variance, symmetric data, and skewed data, and the identification of outliers. So that's what's going to be taught in the third term. But for Rena today, we're going to start with histograms again. And in the revision for the 5-number summary, I'm going to send you videos of that so that you guys can revise super easy from last year. Okay. Any questions so far? Any questions so far? Ndlovu, are you fine? Please confirm, Ndlovu, if you're fine. Okay, proper stuff. So now I'm gonna get into it now. Okay, let's zoom in. Okay, statistics. So now I'm gonna develop something. I'm gonna like derive the so-called histogram by using an example. Okay, take this example here. You've got um, you've got 10 students writing a math test, and then the marks are later published. So you've got 10 students in class, then each of the marks is given on the second column, the mark column. Okay, someone gets 24, 35, 53, 79, and so on until 95. Okay, sharp. These are the class marks. So now a question comes and says, how many students got a mark between 20 and 40? So the number of students that got a mark between 20 and 40 is this first student. They got a 24. This student got a 35, and then that's about that. The next student got a 53, which is outside this sort of interval. So we only have 2 learners who got a mark of a mark between 20 and 40. Are we all happy with that? Please show by way of a thumbs up if you're happy. Okay, proper stuff. So we've got 2 learners. And then the second question asks you how many students got a mark between 40 and 60. All right. So we've got this mark, that mark, that mark, and that mark. So you've got 4 learners who got a mark between 40 and 60. Let's put a 4 there. The next question, how many students got a mark between 60 and 80? Let us see how many. We've got 67, 78, 79. So we've got 3 learners who got a mark between 60 and 80. Lastly, how many learners got a mark between 80 and 100? So it's only one person. So we put a 1 there at the end. Okay. So that's about that. So now there's something that I need to draw attention to that's super important. Conventionally, when you're dealing with intervals, if they give you like something like this, a statement like this, between 20 and 40, you're gonna write it like this conventionally: 20, sorry, to 40. Okay, you exclude the lower bound, you include the upper bound, unless they give you an exam that maybe, for example, you've got something like this, then you take it that way. Ne? But if they don't like specify whether or not the minimum value, the minimum limit is included, the maximum limit is included, you do this. You exclude the minimum limit, you include the maximum limit. Does that make sense, Buhle? Sapan, does it make sense? Does it make sense? Yes or no? Yes, yes. Can't you see the screen? The whiteboard. You don't see the whiteboard? Okay, okay, that's fine. I'll go again. Can you see it now? Okay. So, Tsapang couldn't see the whiteboard, so I'm going to start from scratch. So, we're just 5 minutes into the session, so it's not a train smash. Okay, so as I said, we're doing statistics, grade 11 statistics. And then in this session, we're just focusing on the so called histogram and Ogive or Ogive, however you pronounce it. So, I'm going to derive those two concepts using an example. This is the example. It says 10 students write a test and later have their marks published as shown below. So we've got 10 students who write a math test, and then after that, the marks get published and posted somewhere, maybe on a notice board or something. So the first learner got 24, 35, 53, and so on until 95. Okay. Now let us do the questions that follow. These questions will are part of the build-up to the two concepts, the histogram and the ogive. Yeah. So it says how many students got a mark between 20 and 40. This is the question. So let us look at our data. We've got this student, 24 is a mark between 20 and 40. 35 is also a mark between 20 and 40, while 53 is not a mark between 20 and 40. So therefore, we only have two learners who got a mark between 20 and 40. We go to the next question. It says, how many students got a mark between 40 and 60? Let's move. We've got 53 here. So 53 is a mark between 40 and 60. 52 as well. 57 is a mark between 40 and 60. And 60 as well is essentially a mark between 40 and 60. So we've got four learners who got a mark between 40 and 60. So as our answer, we write 4 there. We move. Um, uh, Question C says, how many students got a mark between 60 and 80? Okay, we go back to our data. We've got 67, that's a mark between 60 and 80. Got 78, it's also a mark between 60 and 80. Got 79, it's also a mark between 60 and 80. So therefore, we've got three people that got a mark between within that interval. So we put 3 there. Lastly, how many students got a mark between 80 and 100? So only have one learner. So just put 1 there. Easy peasy, ne? Okay. Remember, what am I doing? I am deriving the so-called histogram and ogive. All right. So those are the questions. I want to draw your attention to something, as I said earlier. Yeah, something ultra important. So whenever in maths or in statistics, they talk about something like this, like they tell you an interval between 20 and 40. How you should write it mathematically, write it like this. Exclude the minimum value or the lower bound and include the maximum bound. This. Okay, unless in an exam they literally give you something like this, then you follow that. But if they don't specify, then you just follow this convention. The lower bound is excluded and the maximum bound is included. Does that make sense, Bafwetu? Thumbs up if you're happy in the comment section, or you could just speak into the mic. That's allowed. Okay. Okay, so I'm saying if they ever say in the exam or textbook, whatever it is, and they give you the statement between 20 and 40, if you want to write it mathematically, you write it like this, ne? So meaning that we exclude the lower value, we include the upper value. For example, if someone here got a 20, it would not fall under this interval because why? The 20 is included here. Okay? But if someone gets a 40, it would be included in this interval because a 40 is included by way of the square bracket. Does that make sense? Proper stuff. So now when you look at the second question B, yeah, it says how many students got a mark between 40 and 60. Okay. So now we chose this 3. 53 is a mark between 40 and 60. 52 is a mark between 40 and 60. 57 as well is a mark between 40 and 60. And then 60, we also included 60. Why? Because we assume that this statement between 40 and 60 is this mathematically. it includes the 60. Do you see? Hence, we included the 60 as well. So we have 4 of them. 1, 2, 3, 4 numbers that are between 40 and 60. Do you understand, my sister? Please confirm if you understand on the comment section. Please confirm. Okay. All right. Proper stuff. So now, okay, we got all of these answers here. We're good. So now I want us to draw a table out of these values. Yeah. Because remember, we established that in our table or in our data, there was two students who got a mark between 40 and between 20 and 40. There was 4 students who got a mark between 40 and 60. There was 3 students who got a mark between 60 and 80, and then 1 student who got a mark between 80 and 100. So let us draw a table from this. Ne? Let's draw a table. So here's our table. Let me just get it closer so that you guys can see. Or let's do this. Did I put it this side? That side. Okay. Okay. This is the same stats. Okay. So I drew my table here. Those who got an interval between 20 and 40, we've got 2, 40 and 64, 60 and 83, 80 and 100, we got 1. Okay, so that's our table, right? So instead of us writing like sentences within these cells, rather let's write these statements mathematically. So instead of us writing between 20 and 40, let us put it this way. Does it make sense? Yes. Okay. Instead of us writing between 40 and 60, let us put it this way. Instead of us saying numbers between 60 and 80, we just put it this way. And then between 80 and 100, we put it that way. So we're literally like redrawing the table. We're just replacing these sentences with like the mathematical way or version of themselves. So yeah, that's it. So yeah, so sharp. So we've got 2 students, number of students in the interval. We've got 2 students who got a mark between 20 and 40. We've got 40 students, 4 students who got a mark between 40 and 60. 3 students who got a mark between 60 and 80, and then 1 between 80 and 100. Are we all happy so far with the data? Before I get into the graphs, start explaining the graphs or the histogram itself. Are we all happy? Yes. Gosnati, are you happy, bro? Okay, proper stuff. Remember, when you're not happy, you just ask, ne? Don't be shy. Okay, sharp. So now, I'm gonna use this stat, this table rather, to draw a graph. Okay, so whenever you've got a table of numbers, a math student must have that edge to draw a graph or line graph or bar graph. Okay, so a bar graph or line graph, any sort of graph, gives us a visual picture of what's going on. So I took that table, then I drew this graph over here, a bar graph. Okay, on the x-axis I put the interval. Okay, the interval 20 to 40, 40 to 60, and so on. So 20 to 40, 40 to 60, 60 to 80, 80 to 100. Again, and then on the y-axis I put the number of students in each interval. So number of students in the interval. That's about that. Okay. So now when you draw your histogram, ne, your scale must make sense. So for example, on your y-axis, or rather on the number of students in the interval, we've got 1, 3, 4, and 2. So your scale must be small. We could go maybe 0, 0 0.5, 1, 1.5, and so on. It mustn't be like 10, 20, 30 or something like that. It must match the statistics or the data that you're given. Okay, and then same with the intervals. You must check the type of data you have or the type of the size of numbers you have on the interval. Then you scale your x-axis based on that. Does that make sense? Yes, no? Okay, proper stuff. So let us go ahead and draw the bar of each of the intervals. On the first interval, we've got 20 to 40, we've got 2 students. So 20 to 40, 2 students. We draw a bar like that. From 40 to 60, that's 40 to 60. We've got 4 students. We put a line there, we draw a bar like that. Then 60 and 80, we've got 3 students, 60 and 80. 3, we draw a bar like that. Lastly, from between 80 and 100, we've got 1 learner. Got a bar like that. Make sense? Questions? Please fire questions. Okay, proper stuff, ne? Sharp. So this is what we call a histogram. There's nothing complicated here. This is what we call a histogram. We did that last year in grade 10. So yeah, that's a histogram. Sharp. And from this histogram, I could actually like draw another type of graph. A graph we call like a line graph. Let's put it this way, a line graph, what we call a frequency polygon. So what I can do is instead of me drawing bars, right, I could plot points, yeah. So for 20 to 42 students, I just put a dot there. For 40 to 60, I've got 4 students, I just put a dot there. Then from for 60 to 80, I've got 3 students, I put a dot there. And lastly, between 80 and 100, I've got 1 learner, put a dot there. Then I just join the dots like this. You see? So from this table, I could make a histogram or a line graph. Okay. They're the dots. So literally do that. Connect those dots, just like that. With a ruler, make sure that your dots are connected straight. So this is like a nice finished diagram for the line graph and the histogram. And then let us remove the histogram so that you guys can see how the line graph looks like. This is what it looks like. Okay. So this tells you there's 2 learners who got a mark between 20 and 40. There's 4 learners who got a mark between 40 and 60. There's 3 learners who got a mark between 60 and 80. And then there's only 1 learner who got a mark between 80 and 100. So this is what we call a frequency polygon. Never mind the lines in the background. It's just the graph itself, the program I used to draw it. But yeah, this is what we call the frequency polygon. There's nothing complicated there. It just talks about the frequency. Or another way to put this is to say the number of students. Instead of you saying the number of students in the interval, you can say the frequency. You can replace that with frequency. Okay, that's still the same thing, literally the same thing. Fair? So now there's another interesting graph. Ne? There's another interesting graph we could draw from this information. Okay, so I'm gonna go back and rewrite this table. Rewrite this table, yeah. Rewrite this table and do some further analysis. Just give me a second. Okay, here's the table, ne? Now, before we draw this new graph, ne? Can you guys answer this question for me, ne? It says from the table, how many students got a mark of 40 or less? Can someone tell me how many students got a mark of 40 or less from this table? How many learners got a mark of 40 or less? 2, ne? 2, yes. 2 learners. Yes, 2 learners got a mark of 40 or less. Why? Because we've got 2 learners who got a mark between 20 and 40. And then above that, we've got 40 and upwards. So therefore, it's only 2 learners. So 40 or less is 2 learners. What about the number of learners who got a mark of 60 or less? How many are those? It's 40 or less. 4, ne? Someone says 4. Okay. Look at it again and give me the correct answer. How many learners got a mark between 60 or less? Not between 40 and 60. No, 60 or less. 6, ne? Why? Because these 4 learners here in this interval, the learners inside this interval 40 to 60, yeah? There's 4 of them, right? Then below that, we've got 2 learners who got a mark between 60, between 20 and 40. These learners still got a mark that is less than 60, again. So therefore, we've got 6 learners. You just add these two. 2, and 4. So you've got 6 learners who got a mark of 60 or less. Make sense? Yes, proper stuff. Okay, next question. How many learners got a mark of 80 or less? 80 or less? Someone? How many learners got a mark of 80 or less? You can type if you want. Someone says 9, yeah? Someone says 9. So how many? The question was how many learners got a mark of 80 or less? So in this interval here, we've got learners who got a mark of between 60 and 80. We've got 3 of them, right? And then the interval before that, we've got a number of 4 learners who got a mark between 60 and 40. But these 4 learners still got a mark of 80 or less. We also include these ones, these 2 learners in the first interval. So therefore, you just simply add all of this. So it's 3 plus 4 plus 2 gives you 9. So 9 learners got a mark of 80 or less. Lastly, how many learners got a mark of 100 or less? 100 or less. Somebody type or somebody say something. How many learners, according to the table, got a mark of 100% or less? Thank you. Yeah, 10 learners. Thank you, Sally, for sharing the class. Appreciate that. Okay, so yeah, so we've got 10 learners who got a mark of 100 or less. Why? Because in this last interval, between 80 and 100, learners who got a mark between 80 and 100 got only one learner. But if you're asking for the number of learners who got 100 or less, it's literally all of the learners in all of these intervals that are less than 100. So therefore, we've got 10 learners. So just simply add everything here, we've got 10. Now, whenever you are answering such questions, please note that the last number you get there is literally the number of data points. So you remember that we were studying we were studying the marks of 10 students. So whatever you get there at the end must always be the number of your data points or the list. So in our case, it's 10 students. So if you don't get a 10, if we didn't get a 10 here, we would have known that we might have made a mistake somewhere there. Are we together? Kosnati? Yes, yes, yes. Easy peasy, lemon squeezy. So what I'm gonna do is I'm gonna add like a column there at the end, like a third column, ne? And call it the cumulative frequency column. Okay, I'm gonna add it there. It's literally what we just drew, ne? So it's remember we had the interval, the number of learners or students in the interval, or the frequency if you like, frequency, and then the one I just added now is what we call the cumulative frequency column. Okay. Now, how does this column help us? Look at this, ne? On the first cell on this column, this cell, ne? The 2 means is the number of students who got a mark of 40 or less. So you literally look at the upper bound on that interval, and then that's that upper bound or less. You look at this 6 over here. This is the number of students who got 60 or less. We look at the upper bound and less. Does that make sense? We got that by adding these 2 and got a 6 from the previous column of frequency. Then this 9 here is the number of students who got 8 or less. We look at the 9 and the upper bound, that's 8, that's 8 or less. So you can get that number by just adding all of these. 2 plus 4 is 6 plus 3 is 9. Okay, that's what it is. And lastly, this 10 is the number of students who got 100 or less. You look at the upper bound, that's 100 or less. So it's 10 of them. How did you get that 10? You just simply added everything there and got that 10 there. So yeah, that's what this cumulative frequency column means. Does that make sense, my daughter? I want to hear your voice. Please type on the comments section. You're free to type if you can't speak into the mic. You're free to type. Thank you, Hami, for joining. Thank you, Pahlela, for joining. Thank you, Letswalo, Jaden, Sabelo, Fifi. Okay, sharp. So you guys understand? Sharp. So I'm gonna throw like a new sort of graph from this information. So what information specifically am I going to use to draw this new graph? I'm going to use this frequency, cumulative frequency column, and I'm also going to use this interval column. How am I going to use it? I'm going to plot like points on a Cartesian plane, like a Cartesian plane. And then I'm going to do is um, on the x-axis I'm going to put the interval, and on the y-axis I'm basically going to put the frequency, cumulative frequency. And then now I'm going to plot coordinates. How am I going to generate the coordinates? The x coordinates would be the upper bounds of each interval. So for the first interval, I've got an upper bound of 40. I'm going to go 40. And then what's the y-axis? The y-axis will be the cumulative frequency value, that is 2. And then the next point will be, I'm going to take the upper bound of the next interval, and then the y coordinate of it will be the 6 there on the cumulative frequency column. So the next one is the upper bound there, 80, then the 9, lastly the 100, and the 10 there. Okay, so I'm going to do that. So these are the coordinates, as you can see there. Literally what I just showed you. How we got the coordinates, I'll just repeat quickly. I take the upper bound of the interval, which is 40, as my x coordinate, and then take the cumulative frequency value as our y. Upper bound, my x coordinate, this as our y. Upper bound, x coordinate, this as our y. Upper bound, x, y. Okay, so yeah, so we're gonna use these coordinates to draw what we call a frequency, cumulative frequency polygon. Ne? Cumulative frequency polygon. So it is a graph that we draw from the values, or from the numbers generated by the cumulative frequency table or column. So here's how it looks like. Let's get this very close to it. I'm gonna move this. Yeah, I'm gonna put it next to it. Zoom in. Okay, let's just focus on the coordinates quickly and the graph itself. Okay, so let us look at each point. Okay, on the x-axis we have the interval. On the y-axis we've got the cumulative frequency. In the exam, if they ask you to draw this, they're always gonna give you like a nice Cartesian plane. They call it like an extra A or B, whatever it is. They always give you this. Sharp. So let us look at the points. So 40 and 2. So on the x-axis I've got my 40, and the y-axis I've got my 2 there. Put my point there. And the next point, 60 and 6. X-axis 60, y-axis 6. Got my point there. 80 and 9. 80 and 9. 9 is a number between 8 and 10, somewhere there. So here's my point. Lastly, 100 and a 10. So I've got 100 there and a 10 there. So I've got a point there. Okay. So please note that as I said not so long ago, the last value there on the cumulative frequency column is the number of data points you have. So remember we were looking at the marks of 10 students. So this is confirmed there. This is also confirmed on the cumulative frequency polygon, this thing. This last value there, this y value there, is also the number of data points. Okay, so yeah, from those points, you guys can clearly see I've joined those points and drawn some interesting graph there. So I joined the points and drew this graph. Okay, then the last thing you do on this graph, you must look at the you want this line to start somewhere there or there or there. You want it to start from the bottom. So how to decide on that? You look at the lower bound of the first interval. The lower bound is 20 of the first interval. Then that's where your graph will start. So it's gonna start at 20, the lower bound of the smallest interval. Then you extend the diagram like that. So if you look at the diagram closely, it looks like it's S-shaped. It looks like the letter S. Do you guys see it? So this is what we call the cumulative frequency polygon. They call this the cumulative. Cumulative frequency polygon. Polygon. For short, Ogive. Some people call it Ogive, Ogive, whatever. It doesn't matter. But that's the story there. Ne? Any questions? Feel free to ask questions about Freighty before we move. Fire questions, fire questions, fire questions. Pito, fire questions. Pito, you're late today.